In our first design, we had a big box with 2 big wheels and 2 small wheels. We felt that having a box instead of a rectangle would save on weight. However, when we thought about it some more, the box design would become very unbalanced with a long lever. In our second design, we decided to go back to a rectangle, but we still wanted to save on weight, so we removed the middle of the rectangle. We then 3D printed the chassis for this design as a proof of concept. We wanted to make our next design even lighter. First of all, we ditched the previous U shape and made the body out of 2 pieces of MDF joined together in the middle. We removed some material from these pieces to save on weight. Originally, they were both rectangles, again to reduce weight. We ditched the idea of having the 2 pieces connected everywhere. We decided to connect them only with 3 little strips of MDF in the center of the car. This would minimize weight. These 3 bands would also hold the mousetrap. We decided to only use 2 wheels as well. We wanted to use a relatively thick wheel in the front and a very thick steamroller wheel in the back. These thick wheels would increase friction, but hopefully they would make our car more stable because of the increase in surface area. Now it was time to make our card model. We kept most of the design the same, however we changed some things. We decided that to get better adhesion with the mousetrap, we would make the connecting band one solid piece instead of 3 separate ones. We also decided to cut a slit in both hull pieces to put this band in. This would provide better structural integrity than gluing the bands on top of the 2 hull pieces. We also decided to ditch our 2 thick wheel designs. We didn't really think through how we would make these wheels with a laser cutter, and now we realize it is pretty much impossible. The only way we could have made them is by stacking multiple 2D wheels together. This would make the wheels incredibly heavy. Originally, we wanted to make them hollow. We thought that with this design, we were going to 3D print it. There isn't really a good reason for this, but we thought that we could maybe reduce the infill on the print to save weight. We could also bevel the edges of the wheels to reduce friction. To make the wheel edges thinner with the laser cutter, you need to make the whole wheel thinner. This would make it very fragile. However, none of the 3D printers were working at the time, so we had to resort to laser cutting. Now it's time for a Corel Draw. Good old Corel Draw. I made the great mistake of letting Thomas handle something for once. Oh, and I don't need to tell you how that went. Now, I'll say this in the nicest way possible.
Thomas Alexander Bailey, what on earth is this Make-A-Wish abomination?
So anyway, that didn't work out for us. So we got Mr. White to make a new wheel.
Thank you, Y, for those warm words of encouragement. Now it was time to assemble the mousetrap car. At first, everything was going swimmingly. We started out gluing everything. However, right before we were going to put the mousetrap on, Y thought it would be a great idea to drop the car. Funny that. The wheel broke, and this was because the outer end was far too thin.
Why?
We wanted our replacement wheel to be far more sturdy, so we made it solid instead of hollow. We knew that this would make the car heavier, but we were willing to sacrifice weight for structural integrity. We also decided to replace both back wheels so that both sides of the car were perfectly balanced. Now we added the mousetrap, lever and string to our car. This was before we had gotten our replacement wheels, but we wanted to see if the car would function at all. When we tested the car, the back wheel would just spin out and not provide any traction. At first, we thought this was because of the broken wheel, but later on, we would be proven wrong. Now we added our 2 replacement wheels. It was time to test the final design of the car. During our testing, we realised that the wheels were still spinning out. Looking back, we saw that our lever was extremely bent. In the first second, when the wheel would spin, the lever wouldn't move forward, it would just straighten out. This means the majority of the mousetrap's energy is dedicated to straightening the lever instead of moving it and spinning the wheels. This caused the car to only accelerate after the majority of the string had unwound from the axle. Another problem could be the lack of friction with the polished hardwood, which also made our wheel spin out. We tried to fix this issue with masking tape on the wheel, but it didn't work. Now that I knew what our problem was, I made some changes. I added structural reinforcement to the lever so it wouldn't bend, and I put the car on friction-rich carpet. This really worked, as you can see in the slow-motion footage. The wheels do not spin out, and the car accelerates right away. The only problem was that when the lever went down, it hit the ground and lost a lot of speed. If we were to continue developing this design, then we would add cushioning to the lever so it couldn't hit the ground. Otherwise, we are very happy with how the design turned out.
Look at